Hello, Math 45 students. We will be picking up on page 10, section 7.3, Systems of Nonlinear Equations and Inequalities in Two Variables. A system of nonlinear equations is a system of two or more equations in two or more variables containing at least one equation that is not linear. So for example, what we can have is we can have a parabola and a line. So three different things that can happen. No solution, meaning that there's no intersection. One solution, meaning it intersects at exactly one point. Or two solutions, right? When you see the parabola, that red graph, and that line, the blue one, intersecting, it can intersect twice. So here in this chapter section, we cannot do the matrix because we have a degree 2. So what you can do is you can either do a substitution or elimination. I think for this one, and it really is your choice, right? So you get to choose. So your choices. You can either solve this by a substitution or by elimination. So I don't know, I guess I'm going to try to choose this by a substitution. Why not? So if I'm going to choose this by substitution, I'm going to get one of these equations isolated. So it looks like the y is already isolated. So that means I am going to plug in for the y variable everything I see here. So here I go. Equation number 1. I have x minus, and now there's the y. So this is what I'm plugging in, x squared plus 1. And I have an equals to a negative 1. So remember that this is really like a negative 1 that you are going to distribute inside the parentheses. So that I have x minus x squared minus 1 is equal to a negative 1. And here I can add 1 to both sides. So I can get that x minus x squared is equal to 0. So rewriting this in standard form, meaning from biggest exponent to smallest exponent, I would have a negative x squared plus x is equal to 0. So then from here, I'm going to factor, and I can factor a negative 1 out, or actually a negative 1x out, there we go. So I'm left with x minus 1 is equal to 0. So I have a negative 1x is equal to 0, and x minus 1 is equal to 0. So here I have that x is equal to 0, and x is equal to a positive 1. So remember, here are my two possible x values. I need to figure out the corresponding y values. So I'm going to check each one out. So let's say for the first one, I'm going to let my x equal to 0. Let's see what I end up getting. So from my equation number 2, I have that y is equal to an x squared plus 1. So y is equal to a 0 squared plus 1. So that y is equal to 1. So this tells me that the ordered pair is 0, 1, where x is 0 and y is equal to 1. So now, let's see what happens when x is equal to 1. So when x is equal to 1, I'm going to go ahead and plug it into that second equation again. Why not? I have y is equal to x squared plus 1. So y is equal to a 1 squared plus 1. So y is equal to 1 plus 1, which is 2. So that gives me the ordered pair 1, 2. So it looks like I'm going to have 2 points of intersection, and those 2 points are going to be 0, 1 and 1, 2. Moving on to our second problem, it says that now we're going to have a circle and a line. So again, you have your choices, right? You can do substitution or you can do elimination. I'm going to go ahead and do substitution because I see that the y variable is isolated, so I can plug that all in. So doing a substitution, I'm going to have from my first equation that x squared plus y squared is equal to 5. And what I'm plugging in there is a 3x minus a 5. So now I really have x squared plus, and I have 3x minus 5 times 3x minus 5 is equal to 5. So I'm going to go ahead and FOIL this out. When I FOIL this out, I will get a 9x squared minus 15x minus 15x plus 25 is equal to my 5. And remember, FOIL is your first outer inner last. Okay. So now when I add these together, I have an x squared and a 9x squared, so that's going to give me a 10x squared. I have a negative 15x and a negative 15x, so that's going to give me a negative 30x. And I have plus 25 is equal to 5. So then from there, to move the 5 to the other side, I'm going to subtract it. So I have 10x squared minus 30x plus 25 minus 5 is 20. So then from here, I can factor, and it looks like my GCF is going to be a 10. So I'm going to factor. GCF is a 10. So I'm left with an x squared minus a 3x plus 2 is equal to 0. And hopefully you guys are becoming a little bit more comfortable with factoring. To multiply to 2 is 2 and 1. To add it to negative 3, only if they're both negative. So now I have that 10 is equal to 0, x minus 2 is equal to 0, and x minus 1 is equal to 0. Well, 10 equal to 0 doesn't make any sense, so you throw that one out. But here I have that x is equal to positive 2, and x is equal to a negative 1. So these are your possible x values, and you need to find corresponding y values. So that's when I'm going to move it over. So let's say for the first one, I'm going to let that x is equal to 2, since this is this one here. So if we let x equal to 2, I'm going to look at my second equation, which is y is equal to 3x minus 5. So y is equal to 3, and that x value that I'm plugging in is a 2. So y is equal to 6 minus 5, which is a 1. So then this solution is 2, 1, where the x is 2 and the y is 1. Now I'm going to try my x is equal to 1. And so if I look at that equation, I have y is equal to 3x minus 5. So that one value I'm plugging in for x. So I'm going to have that your y value is equal to 3 minus 5, which is going to be a negative 2. So then this ordered pair is 1, negative 2 for your x and y value. So I have my solution of 2, 1, and 1, negative 2. And now for this example, I am going to have two circles. I know that these are two circles because I have an x squared and a y squared. So that's how I know I have circles, right? X squareds and y squareds. Or actually, it's an ellipse, right? So it's not a perfect square root. So what we want to do for this one, because they're squares, instead of doing a substitution, this is the one that I want to do elimination. Elimination, because you have an x squared and y squared. So both the x and the y are squared, and this is what tells me to do elimination. So that tells me that for the first equation up here, if I'm going to do elimination, I want to multiply it by a -3. So I'm going to have a -3x squared minus y squared is equal to a -78. My equation down below doesn't change. I still have a 3x squared plus a 25y squared is equal to 100. Now I'm going to be adding these equations together. So I can see that the x's cancel. Perfect. 25 minus 1 is a 24y squared. And if I will have 100 minus 78, that's going to give me a positive 22. So now I have y squared is equal to 22 divided by 24. So then my y squared, oh, I see what I did wrong here. And this is where I can see it. I definitely distributed 3 here and then -3 here, but I forgot to distribute it there. So because I forgot to do that, then my y value is going to change slightly. But that's okay. At least I was able to write all of my process down, so it doesn't throw me off too much. So that was just my 22y squared and your positive 22. There we go. So I got lazy and I didn't draw my arrow, so it's a -3y squared. So -3 plus 25 is a positive 22. And then from here, I can divide both sides by 22. So I can get that y squared is equal to 1. Well, to get the 1 by itself, I'm going to square root both sides. But when you square root, you can't forget the plus or minus. So you have y is equal to 1, and y is equal to a -1. So now you have 2 possible y values. So now you need to figure out your x values that go along with this. So you're just like, okay, well, what I can do is I'm going to plug these equations in. So I'm going to try the y is equal to 1. Let's see what happens when y is equal to 1. Well, let's work with this equation, and I'm going to work with the top equation just because it looks a little bit nicer. So I have x squared plus y squared is equal to 26. So x squared plus squared is equal to 26. And that variable, or that value that I'm plugging in for y, is 1. So now I have x squared plus 1 is equal to 26. So then x squared is equal to 25. So now, to get this x by itself, I need to square root it. Don't forget the plus or minus. So that x is equal to 5 and x is equal to -5. So I just found that I have my ordered pair 1, 5 and 1, -5. So this is an ordered pair and that's an ordered pair. And don't forget, you still have the y is equal to -1. So I'm going to let my y equal to a -1, and let's see what comes out. So I still have x squared plus y squared is equal to 26. But now that value that I'm plugging in is a -1. So I'm going to get x squared plus -1 squared. -1 times -1 is a positive 1. So it actually ends up being exactly the same. So x is equal to 5 and x is equal to -5. So now your ordered pair is 5. So the ordered pair is 5, -1, and -5, -1. And remember, it should always go x, then y, x, then y. So it looks like I wrote these backwards, but that's okay. I'm able to go back because I wrote all of my steps. So I don't have to erase everything. Just remember the x comes first. So 5, 1. So you have your x and your y. So you have your x and your y. So -5 comes first, and then your y value. So order matters. Always write the ordered pair x, y. where x comes first, then y. So this example is a perfect example of me rushing. So you really want to make sure when you're doing your math to go slowly. So remember to distribute, right? I forgot that 3 that I distributed in. And here I need to make sure that I write the x first, then the y value. And so for this one, with the circle and the ellipse, I end up getting 4 different answers for my final equation. Okay? All right. So now let's take a look at this graphing the inequality. So here, when I'm graphing this, because it's an inequality, I know it's going to be shading. Okay. When it's like this or like this, greater than or less than, it's going to be a dashed line. When it's greater than or equal to, or less than or equal to, is going to be a solid line when I'm looking at the inequality. So this inequality, when I'm looking at it, this tells me I'm going to have a dashed line. So dashed line looks like this. So let's think about if we were to have y is equal to mx plus b, where m would be your slope and b would be your y-intercept. So if I have y is equal to x squared plus 1, this is actually a parabola because I have a degree 2 on the x. So I know that this is linear, so it's a line, and the degree 2 would be a parabola. So what might be good when you're drawing a parabola is to just do some ordered pairs. That might help you out. And some good values maybe would be 1. If I plug 1 in, 1 squared is 1 plus 1 is 2. If I plug in a 2, 2 squared is 4, 4 plus 1 is 5. If I plug in a negative 2, negative 2 squared is 4, 4 plus 1 is 5. So, and even if I did 0, 0 squared is 0, plus 1 is 1. So I have 0, 1. I have negative 2, 5. I have positive 2, 5. And 1, 2, I guess. So it would have negative 1, 2. So this is more or less what my graph of the parabola looks like. And remember, it's a dashed line. So there's my dashed line. So now what I need to do is figure out how to shade. Well, if I have this, this is telling me that y is greater than. So that tells me to shade above y-intercept. So if this is my y-intercept up here, then I need to shade above it. So when I shade above it, then I'm on the inside of my parabola. And some people do some really good shading. But that's me shading, okay? So I know my shading is going to look something more or less like that. Now, for the second one, now I'm dealing with two parabolas at the same time. So I need to be careful. So I'm going to look at this first one. When I look at this first one, I want to put it so that y is isolated. So this is x squared minus y less than or equal to 0. So I'm going to subtract the x squared from both sides. So negative y less than or equal to a negative x squared plus 0. From here, I'm going to divide everything by a negative 1. And remember, whenever you divide by a negative, the inequality changes. So now you have y, and since you divided by a negative, that's going to change. now it's going to be greater than or equal to, and a negative divided by negative is a positive, so now you have x squared. And 0 divided by negative 1 is just 0, so it's just going to be x squared. Now I'm going to look at my second equation here. For my second equation, I have 2x squared plus y is less than or equal to 12. So I'm going to move the 2x squared over so that y is less than or equal to a negative 2x squared plus 12. So for this first one, I can go ahead and give you some values. So if I plug in 0 for x, 0 squared is 0. If I plug in a 2, 2 squared is 4. A negative 2 squared would give me a positive 4. So this graph is going to be a solid line. So I have 0, 0, I have 2, 4, and negative 2, 4. And here I have greater than or equal to. So that means shade above the y-intercept. So since this is the y-intercept, I know I'm shading above. So if I'm shading above, that's going to be somewhere over here. And I'm not going to really shade it in yet because I want to see what my second equation is going to tell me to do. So for the second equation, I'm going to plug in some values so that way I know what to graph here. So let's see. I can plug in a 0 for x. If I plug in 0 for x, that'll give me a 0, 12. If I plug in a 1, that gives me a positive 10. If I plug in a 2, that gives me a positive 4. Let's see what happens when I plug in a negative 2. Well, that would give me negative 2 times negative 2 squared plus 12, which would be a positive 4 as well. And if I were to plug in a negative 1, well, negative 2 times a negative 1 squared plus 12 is a positive 10 as well. So if I were to plot those points, let's see, I have 0, 12, so that's like up here. I have 1, 10, negative 1, 10, 2, 4, negative 2, 4. So this graph is also a solid line. That's more or less my parabola. And for this one, it's saying, hey, this is less than or equal. So that means I want to shade below the y-intercept. So that's in here. So where it's blue and purple will be right in here. So that is going to be my equation. Okay. So it looks like we have another example. So for this example, it looks like we have a linear equation and a parabola. We know it's a parabola because it has that degree 2. So the first one is going to be my parabola. So I have y greater than or equal to x squared minus 1. So if I plug in some values, if I plug in 0, I would get a negative 1. If I plug in 2, 2 squared is 4, 4 minus 1 is 3. If I plug in a negative 2, that's 4 minus 1, which is a 3. So I have 0, -1, 2, 3, and -2, 3. And this looks like it's a solid line. And it's saying that it's going to be greater than. So I'm shooting above the y-intercept. Okay. So I know I'm somewhere up there. But let's really look at what this is saying. Don't forget you still have your second equation. Your second equation is linear. So for that second equation, you have x minus y is greater than a -1. So then negative y is greater than negative x minus 1. And since I'm going to divide everything by -1, that's going to change the way the inequality is facing, so that y is less than an x plus 1. So remember, this is just like y is equal to mx plus b, where this is your y-intercept, and this is your slope. Your slope happens to be 1, which means up 1, right 1. So from your y-intercept is a positive 1, and your slope tells you to go up 1 over 1. And because of the way this is facing, this is going to be a dashed line. And it's also going to be, since it's y is less than x plus 1, this is less than, which tells me I'm going to be shading below the y-intercept. So if I'm looking at this, looking at the y-intercept, so below the green line, but don't forget it's above the blue line. So above the blue, beneath the green, that place of intersection would be right in here. Right? You're below the green line, but you're above the blue line. Okay, and that is the end of this section. So if you guys have any questions, please feel free to email me. Thank you.